Okay, hi everyone. So in this question, we actually have landing equipment that's going to be thrown from the top of the lighthouse and it's going to land hopefully on a boat. So we actually have a situation where the landing gear is being thrown and it moves in a projectile motion. During that time, the boat is coming in. So we need to have a situation where it'll be just timed right where the boat, once it reaches a certain point, the landing equipment would land nicely into the boat. So what happens is the landing equipment will have a trajectory like this, okay, while the boat will be moving inwards, something like this. Okay, so in this situation, let us first establish our coordinate system. So let's say origin is from here, and we have y pointing upwards as the in the vertical direction as the y coordinate system, and x pointing to the right as the positive x coordinate system. Okay, let's get some initial information. So initial, as my landing equipment is being thrown from origin, that means my x initial equals to 0, y initial also equals to 0. We have a launch speed of 15 and an angle or launch angle of 60 degrees. So that means my v I y equals to 15 sine 60 degrees, while my Vix will be equals to 15 cos 60 degrees. Okay, so at the final condition or final position where the landing gear is expected to land in the boat, my y final would be below the origin, and that value is equals to negative 8.75 meters. Oh, let me put in the SIs, meters per second, meters per second. Okay, the other information that I know, in the y direction, the acceleration is going to be negative 9.81 meters per second. That's based on the coordinate system that we have defined. Okay, so now let's look at another information that we could also get, which is this information, the initial information of boat 2. Of the boat. So let me label it as x2 initial equals to d, and the velocity of boat 2, so v2, as you can see, the direction of the velocity is actually going the opposite direction of the positive x-axis, so therefore it will be negative 0.45 meters per second, 0.45 meters per second. Okay, so what we do first is we want to look at the landing equipment. So let's look at the landing equipment. Okay, so as the landing equipment is thrown and it flies in the air, there's a time of flight that it will be moving in the air. So let me look at finding that time of flight. Time of flight. And this will be the same time that it takes for the boat to move, so that the landing equipment will actually drop onto the boat itself within that time. Okay, so the time of flight, based on the information that we get, the most ideal equation would be y final minus y initial equals to v I y t plus half a t squared. Okay, we have y final, y initial. Okay, let me put in the value. So y final is negative 8.75, y initial is 0, VIYT is 15, sine 60, that would make it as square root 3 over 2 times t plus half. Okay, don't forget the, for acceleration is negative 9.81, so don't forget the negative, t squared. And basically you get a quadratic equation where if you solve it, you get the time as negative 0.56 seconds and 3.20 seconds, positive 3.2. So it's the positive time that we want to take, and while it moves in the y direction in that 3.2 seconds, it also moves in the x direction. So the landing equipment also has an x displacement, and that x displacement, so x final, will be equals to v ix, but although in the x direction the landing equipment actually moves at constant speed, so we just put it as, we just know that it's going to be constant, plus x initial. So in this case, x initial for the landing gear is also 0. Okay, now let's look at the boat situation. So the boat that's coming in, it's also moving at constant speed. So for the boat's displacement, x2 final, so do note that I actually have difference x final and x2 final. So this x final, which I didn't label anything, that is for the landing gear, whereas this x2 final is the boat's position. So this then becomes v2 times t plus x2 initial. And so in this case, v2 is actually negative 0.45 t, and x2 initial, that's actually equals to d. Okay, so the one thing we know, when the landing gear and the boats meet at the same position, or the right position, means that their x final and x2 final would be the same value. So x final will be equals to x2 final, and therefore, so Vix is actually 15 cos 60, that would be 15 divided by 2. So let me just write 15 divided by 2 t. So that's the x final for the landing gear. That will be also equals to the position of the boat at that time, because we want the landing gear to fall into the boat. So there will be negative 0.45 t plus d, and so what we get is 7.5 t plus 0.45 t equals to d, and therefore d would be equals to 7.95 t, and that actually gives us about 25.5 meters. So what that means is that when the boat actually comes in about at like 25.5 meters, then the person who's throwing the landing equipment can only throw his equipment so that it will drop nicely in the boat. Okay, so have a look at it again.